Okay, so I'm going to go over two problems that you're going to see on your homework today. The first one is going to look like this. They're just going to have a different angle probably here. They might have the 45, or they might have a different force at which the kid's pulling the wagon, right? So if they're pulling 12 pounds, in that direction, we want to break it down to what's the force horizontal and what's the force vertical. Well, since it's a 45-degree angle right here, these two amounts are going to be the same thing. So once I calculate one of them, I don't need to worry about the other one. The two legs are equal in a 45, 45, 90 triangle. So if the hypotenuse is 12, how do you get to the leg? You could divide by the square root of 2. So this amount down here is 12 divided by the square root of 2. They're probably not going to like you to leave it like that. So we multiply by the square root of 2 over square root of 2 to rationalize the denominator. And we end up with 6 square root of 2. So how do we tell people that's the horizontal amount? We put an I after it. That tells you that it's a horizontal amount. So right over here, we're going to put, just the 6 square root of 2 part, and then the I is telling us the horizontal part, and then I'm going to put 6 square root of 2 again because I have a 45-degree angle. If you get a different angle, be careful. You might need to do the cosine, right? So you're going to take the radius, like 12 times the cosine of 40, whatever angle you get. I'm not going to put 45 here because it makes me look like I don't know the square root of 2 over 2 is involved. You know what I'm saying? Like, that's what I'm really doing here. I'm dividing by the square root of 2 to get to the leg. Anyways, you just have to figure out the horizontal component and the vertical component, and you put those in the boxes. Number 1 is going to be kind of straightforward compared to number 3. So I'm going to skip to number 3. 1 and 2 are going to be similar. Number 3, maybe things get a little bit more challenging. If we're going to head at 45 degrees, like east of north, I'm going to make a drawing that looks, let's see here. Let's put down a north heading here, okay? So this is north. And if I go 45 degrees east of north, so let's say I draw something like this, okay? So in other words, this angle right here is 45 degrees, right? Because this angle over here is 45 degrees. Doesn't matter which way you think about it. But what I'm going to try to do is I'm going to try to come up with what is that vector right there. Well, that vector is going to have an I component and it's going to have a J component, just like the previous one I did. And how do I get from the hypotenuse to one of the legs? I divide by the square root of 2. So I go 530 divided by the square root of 2, and then plus 530 divided by the square root of 2. So I've got that vector. That's my plane, right? This is what the plane's trying to do. All right, then let's go to the wind. Where's the wind at? It says, the wind is 30 kilometers per hour in the direction of north, 30 degrees west. So 30 degrees west of north. So I'm going to make something kind of short, because if this is representing 530, 30 is a lot less than 530, so it's got to be a lot smaller. And then this is the 30-degree angle right here, because it says that we're 30 degrees west of due north. That's what they're talking about there, okay? So what does that make this angle, and what does that make this, leg here? So, well, I've got a 60-degree angle right here. That makes this the short leg, so it must be 15, because it's half of the hypotenuse when it's the short leg, 15I. And then this one over here is 15 square root of 3J. All right, so if I want to just write out the wind vector, then I put those next to each other. I go 15, it's got to be a negative 15I because we're going to the left. 15I plus 15 square root of 3J. Now I want to add those two together, and you can see 15 and 530 over square root of 2, they're not going to be able to be combined because this is an irrational number. This is a rational number. So no can do. But it also wants to know what is the ground speed. It wants the magnitude of these two vectors added together. The magnitude, okay? So if I was to graphically add them together, I might do something like this. There's the wind, here's the plane. My resultant vector is going to look like this. It's going to go from here to there, right? And I want to know that magnitude. So let's put down maybe just in my notes, magnitude of the result of adding them together, right? So what's that going to look like? Well, I get 530 over square root of 2 minus 15 underneath the big square root sign. So I'm going 530 divided by the square root of 2 minus 15 squared. Plus, I'm doing Pythagorean theorem right now, plus 15 plus 530 over square root of 2. So I'm going to have 530, oops. Let's do 530 divided by the square root of 2 plus 15 square root of 3. I don't think I said the square root of 3 part. So I'm going to add 15 square root of 3, and I got to square that. That's going to give me my magnitude. So I'm doing Pythagorean theorem. I'm adding the j components together, right? So I'm adding the j components together, and I'm adding the I components together right down here. I hope I'm doing that right. Yeah, it looks like subtraction because that's a negative number, right? You crank all that out, it's going to give you the magnitude. Now, how do I find the direction? This is my y component. Whoa, hold on one sec here. Let me undo a couple squiggles on the screen. Okay, so this is my y whoa, that's weird. My y component is right here. This is my x component over here. So I want to take the inverse tangent of the y, so 530 over square root 2 plus 15 square root 3, and the x is down here, 530 over square root 2 minus 15, okay? That's what I want to do to get my angle, and man, I got to make sure, like, okay, this is fairly, oh wait, I'm doing the wrong part. This right here is, yeah, this makes sense. I've added the blue and red vectors together, and I get my resultant vector here in black. So the angle, I shouldn't have to like add 180 to it or anything crazy. It should just give me the angle in the first quadrant, right? Because I'm pretty confident I'm in the first quadrant. So I'm going to try that on Desmos. You try doing that, and then keep working on your homework. Call me over if you get stuck. All right? Thanks for watching the video. Appreciate it.